In this video, we're going to look at calculating some indefinite integrals that require the substitution method. So, let's look at A here. So what I notice is I have sine of more than just x. So what I'm going to do is I'm going to let u equal that inside function, 8 minus 3x. Once you choose your u, you calculate your du based on it. It's the derivative of this with respect to x. So derivative of 8 is 0, derivative of negative 3x is just minus 3 dx. Now, I don't have a minus 3 in here, but I need one. Right now that's going to be equal to u, but to get my du in, I need a minus 3 in there. Right there and there will be my du, but to do that, I need to put a minus 1/3 on the outside. So now I have my substitution, minus 1/3. This is going to become sine of u, because that's what we set it to be. And the negative 3 dx is exactly equal to du. And we get a basic indefinite integral, which is minus 1/3. The antiderivative of sine is negative cosine of u plus c. On all the indefinite integrals, don't forget your plus c. The negatives will cancel, and we'll get 1/3 cosine. Now remember, this indefinite integral started in terms of x, it should end in terms of x, so we sub back the 8 minus 3x plus c. And now if you want to check this answer, which is a good habit to get into, take the derivative and make sure it comes out to be what you started with originally. In B here, if it were just secant squared of x, I would know the antiderivative, but it's 4x, so I'm going to let u equal 4x. Therefore, du equals 4 dx. There's my u. I need a 4 on the dx, which means, so I don't change my original, I put a 1/4 out front. So now I make my substitution and I get 1/4 the indefinite integral of secant squared of u, 4 dx is exactly equal to du. The antiderivative of secant squared is tangent of u plus c. And my last step is to substitute back for u, which was 4x, and I get tangent of 4x plus c. When you go to check this one taking the derivative, what you're going to see is this 1/4 compensates for the chain rule that causes us to have to take the derivative of 4x. That's basically what these u substitutions are doing for us. In C here, I'm going to let u equal the denominator, which is 11x minus 9. Therefore, my du is 11 dx. Now, I don't have an 11 dx, I only have dx, so I'm going to put an 11 into my integral, which means I'm going to put a 1/11 on the outside. So I have 1/11 times the integral. This here now becomes 1 over u. This is my du, and now I can take the antiderivative. I got 1/11. The antiderivative of ln, or 1 over u, is ln of the absolute value of u plus c. Last step is to substitute back. In the 11x minus 9, we do need the absolute value because it's not always positive, plus c. So as you go forward, you will make an occasional error as you go to choose your u, and there might be some practice there. But think about some of the things that I chose for u. I was specifically targeting the inside function, or in this last one I targeted the denominator.